Unit 3A, Day 3, Part 2. The angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. Okay, what does this mean? This means that if we have an angle that is bisected, cut in two, remember bisected means two equal parts, so angle APC is congruent to angle BPC, then point C is on that bisector. What that means is that the distance from here to here is going to be exactly the same as the distance from here to here. If angle APC is congruent to angle BPC, then segment AC is congruent to segment BC. If P, then Q. Well, now what's the converse? The converse happens to be true this time. If a point in the interior of an angle is equidistant from the sides of the angle, then it is on the bisector of the angle. So, if we have a point, we'll call it point C, and it is equidistant from the sides of the angle, so AC is congruent to BC, then point C is on the bisector of the angle. So, if AC is congruent to BC, then angle APC is congruent to angle BPC. Good. Continuing right along, how do we use this? Well, we're going to study triangles extensively. Triangles are the foundations for trigonometry and some of bridge building. Find each measure. What do we have? Okay, this is a right angle. This is a right angle. We know that BAC is congruent to DAC. How do we know? Because they tell us with these two little marks. So, if a point is on the bisector of an angle, then the point is equidistant from the two sides of the angle. So that means BC is congruent to DC. This is equal to this, so BC is 7.2. That is the angle bisector theorem. Now we need to find the measure of EFH, given that EFG is 50 degrees. EFH, 50 degrees. Wait, what do we know? EFG is 50 degrees. We know that EH is congruent to HG because we have the marks that tell us so. H is equidistant from E and G from the sides of the angle. So H must be on the angle bisector. Therefore, if EFG is 50 degrees, then EFH must be half of that. So EFH, the measure of angle EFH is 25 degrees. And finally, we need to find the measure of MKL. JM is equal to ML. M is on the interior of the angle, and it is equidistant from the sides of the angle. Therefore, M is on the bisector of the angle. We have to find MKL. That is half of the whole angle. So what can we do? We can say 3A plus 20 degrees is equal to 2A plus 26 degrees. Solve this equation. Find A. Are we done? We are not done. We must substitute the value for A into MKL. When you have that answer, email it to me, please, at Victoria_Collins-Becker at roundroccisd.org, and I will know that you watched your videos and did your homework. If you have trouble with this problem, then email me that. Thank you very much.